So the good news is that the power rule also extends to negative exponents. Remember, when you're evaluating a derivative, it's a linear operator. You can distribute it, kind of. So that means you can find the derivative of each separate term. So negative 4x to the fourth, that derivative is negative 16x to the third. And then x to the negative second, the negative 2 comes down and multiplies out front. And then just like the power rule says, it gets reduced by 1, so it goes to negative 3. And then the derivative of a constant is just 0. So one way of writing this answer is like this, or you could take care of that, the negative symbol, and make it 2 over x to the third. You can use the quotient rule here. This would be your f of x, this would be your g of x, and so the derivative they're looking for would be f prime g minus fg prime over g squared. But personally, I want to rewrite algebraically. I think this could make our lives easier. I got 2x to the fifth divided by negative 2x to the seventh. That gives me negative x to the negative second, because the powers subtract. And then do the same thing here. That's going to be negative 3/2 x to the negative third. And then here, this is negative 1 over negative 2, so that gives us a positive 1/2. And that's x to the negative seventh. Because x to the 0 divided by x to the seventh, 0 subtracted by 7 makes negative 7. And now we can evaluate each derivative. The negative 2 comes down and gets reduced by 1. The negative 3 comes down and gets reduced by 1. And the negative 7 comes down and then gets reduced by 1. So there's your derivative.